All right, let's go on page 70 when we are done. So yesterday we talked about one special right triangle. There are two of them. So today we're going to look at the second one. And so yesterday we did what kind of triangle? What's it called? Isosceles right triangle. It's also called a 45, 45, 90. Good. So there's two different names. It means the same thing. Either one is fine. It's just the exact same thing. Here, this one only has one name, and it is a 30, 60, 90 degree triangle. So this is the 30, 60, 90 Triangle Theorem. Okay. I know. It's like crazy, right? And so we're going to start the same way we did yesterday, which is working down here at the bottom and then coming back to the theorem. So we have here, says, find the height in terms of x. So this part right here, height in terms of x, I want to know what that means from Ellie. Height in terms of x. Can you explain to me what that means? You weren't here yesterday, were you? Okay, so that's okay. Just tell me what you think that means. Exactly, that's all it means. See, she wasn't even here, right? Good. So this tells you a couple things. It tells me that I'm solving for what? Height. I'm solving for the height. And it also tells me that I'm probably not going to get like h equals 3, right? Height in terms of x means that I'm going to have h equals something with x in it. Okay, so I have x's in my answer. It's all fine and good. All right, so now let's look at this triangle that we have, and I want to know what kind of triangle is this from Eric. What kind of triangle is this? Equiangular. Y'all agree with that? Yes. Okay, very good. It's an equiangular triangle, and I'm looking for the height. So since I'm looking for the height, I'm going to go and draw that in, and I'm going to, oh, it isn't really calibrated. I'm going to, okay. All right, I'm going to draw in my height. I'm making it a dotted line just because it's more likely to be straight, even though that's not really even that good. But it doesn't have to necessarily be dotted. But this is the height. Okay. And since the big triangle is an equiangular triangle, it's also what? Kind of equilateral. So what's the length of this side here? 2x. And the length down here is 2x. Right? So does this height bisect the bottom down here? Yes, because this right here, this point is equidistant from the end point, so it lives on the perpendicular bisector, which means these are congruent, which means this is x and this is x. So when I draw in the height here, I end up dividing my equiangular triangle into two, what kind of triangles? Right triangles. Are these two right triangles congruent? Yes. Yes, and we can see that they're congruent by side, 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 or even side, angle, side. Doesn't matter because we have enough information. So since they're all congruent, the big angle up here is 60. What's this angle here? 30. Okay. So drawing in that height gives us a 30, 60, 90 triangle, two of them that are congruent. Everybody with me so far? Okay. So I'm looking for the height in terms of x. Well, starting off, I didn't have a right triangle, but now I have two of them. And so I can use just this right triangle right here. And I can put my information into the Pythagorean Theorem so that I can figure out what h is. Everybody with me? This is going to give me h squared plus x squared equals 2x squared. Did I write all that down correctly? No. I need what? Parentheses, because I need to square the whole thing. So this gives me h squared plus x squared equals what? 4x squared. Okay. Good job. Okay, so now you have to remind yourself, one of the reasons you want to make sure, first of all, you actually read a question and pay attention to directions, is that we have two variables here. And I could solve for either one of them, but I only want to solve for one of them. Which one? H. But you're used to solving for x for most of what you do, right? So it's easy to get inside of one of these kind of things, and you're trying to solve for stuff, so you just start solving for x naturally because you're not paying attention. So that doesn't hurt along the way to kind of remind yourself of what you're trying to get by itself. So I'm trying to get h by itself, which means I'm going to do what? subtract x squared, so I get h squared equals what? 3x squared. And then to get h by itself, what do? Square root. So I take the square root of both sides here. Left-hand side, I get h. And then can I take the square root of 3? No. Can I take the square root of x squared? Yes. So that's just x times the square root of 3. And so to look at kind of like what we did yesterday, if you think about this as the little tree, you can see that as 3 and x squared. So then this becomes x and x, and you can simplify the square root just like you would the rest. You don't need to do this, but you know, if you need to do it so that you can make sense of it, that's what's happening there. Okay, so I get that h is x times the square root of 3. Okay. So we're going to pause here. We're going to go up to the top of the notes, and we're going to do another little triangle. I'm going to give you this. Give you that this is 5, 10, and x. Okay. So can we solve this with Pythagorean Theorem pretty easily? Yes? Okay. So this gives me x squared plus 5 squared equals 10 squared. So x squared plus 5, so it's x squared plus 25 equals what? 100. So x squared equals 75. So x is the square root of 75. Then that can be 3 and 25. So x equals what? 5 times the square root of 3. Okay, so we did this. I didn't even talk to you about angles or anything for this triangle because it doesn't matter. I can do Pythagorean Theorem here because I just have one missing side. This actually is a 30, 60, 90 triangle. This angle right here would be 30. Okay? And so I have 5, 10, and 5 square root of 3, which I can look at as 5, 2 times 5, and 5 square root of 3. Just like right here where I have x, 2x, and x times the square root of 3. Does that make sense? So just like yesterday in the pattern that you have, if this is a 30, 60, 90 triangle, right? This is x, hypotenuse is 2x, this leg would be x squared of 3. So we had 5 and 10, that's what I gave you to start with. We did Pythagorean Theorem to get 5 square root of 3 here, which isn't something that you have to do anymore. Yesterday, the 45, 45, 90 can be thought of as a shortcut to Pythagorean Theorem. This isn't necessarily a shortcut, depending on the information that you have. You may not actually be able to solve the problem without the pattern, because I don't have to give you two sides. I could have just given you the 5, and we could still figure it all out from this, the x, 2x, x squared of 3. So this is 5, 10, and 5 squared of 3. If this was 6, this would be what? 12, and then 6 squared of 3. Does that make sense? Okay, and then again, like yesterday, we are not going to use the x's, even though you may see in some resources x, 2x, and x squared of 3, because you put x on a different spot, it can make things really, really confusing. But we're also not going to use L, because we use that for the 45, 45, 90, and the legs are congruent. That's why we can just call it leg and leg. So let's look at what we are going to call it and what this is going to look like. So this piece, this is the hypotenuse, we know that, right? And then we have the two legs, which are not congruent in the 30, 60, 90, right? But I'm going to give you that this one is 30, this is 60. Okay, so I want you to think, we've got two legs here. We're going to call them the long leg and the short leg. And you've got to know how to put them in the right spots. So I want to know, how would I know where to put which one? How would I know, just by looking at what I have, which one's the long leg and which one's the short leg? Do you win? What about the 30 degrees? The 30 degrees is the longer leg? I don't know what you mean by that, like, because a degree can't be a leg. You're thinking on the right, you're on the right thought process there. So let me ask you the question a little bit different way, because it may be the way I asked it. Okay, how do I know which one is the shortest leg? How could I figure that out? Okay, the smallest degrees tells me what, though? Because the degrees is an angle. So how would I know, how does that relate to a side? You're on the right track. Okay, so let me ask you a totally different question to get you on the right path here. How do you know which one is the hypotenuse? Okay, so this is the side that's across from the right angle. Is the hypotenuse always the longest side? Yes. And so is 90 always the biggest angle in a right triangle? Yes. Okay, so your longest side's across from your biggest angle, right? So my shortest leg is where? Good. And in this particular triangle, which one is the smallest angle? The 30 degrees. Okay, does that make sense? So I know when I have short leg and long leg, the short leg is across from 30, which means the long leg has to be across from 60. Does that make sense? We good? Okay, good job. All right, so here's 30. So across from 30, this is my short leg. And then the other one would be the long leg. Okay. Everything revolves around the length of the short leg. And when you go to label these, if you label them in the same order, the more consistent you are in how you approach something, the easier it is for you just to kind of do it without thinking sometimes. So we're not using X, and we're not using L, but since everything revolves around the short leg, we're going to use S. Now, I just caution you that you have to be able to read your own handwriting and make sure that your S's don't look like 5s and vice versa. Okay, so that's the one thing that might get you confused. You have to make sure that you can tell the difference. Okay, so the first thing you would do is go, all right, you find your 30-degree angle. Here it is. So across from the 30, not a bad idea to draw an arrow so we can get them in the right spots. This is the short leg, so this is S. The hypotenuse, that's usually pretty easy for y'all to identify. That is 2 times S. And then the last one is S times the square root of 3. Okay, so S, 2S, S squared of 3. If you always label them in that order, now, is S always going to be the bottom of the triangle like this? No, but it's always across from 30, okay? So the length of AC is S. The length of BC is S times the square root of 3. And the length of AB is 2S. Okay, so the words that go along with our theorem say, in a 30, 60, 90 triangle, the hypotenuse, so the hypotenuse is 2 times the length of the short leg. And the length of the long leg is the short leg times the square root of 3. Okay? S, 2S, and S squared of 3. And if you can get in there, if you can label what I have in purple and put them in the right spot, that's the most important part. If you just put all 3 of them down, they have to be in the right place, then you'll be able to get through this just fine. Okay? We good? Any questions at this point? All right. So this says find the value of each variable, give your answer in simplest radical form. Always label the triangle in all caps with a little asterisk and an exclamation point. Okay, so just like that reminder I sent you yesterday, you need to put the labels on every single one of these triangles and set up the equations every single time, even if you don't think it's necessary. Through these 2 assignments, I'm going to make you do it every single time. You will get to a point very, very quickly where I will not make everybody do that all the time. But my concern is, and what I know will happen, because remember, I've been doing this longer than you've been alive. I know what kind of mistakes you're going to make. I know who's going to do what, and a lot of times it's the people that, don't think they need to write anything down. They're the ones that make the most mistakes because they don't really have a concept like they think. And there will be times where, yeah, you can look at it, and it's easy just to write it down. But then sometimes you think that's what's happening, and it's not because you haven't thought through enough of them yet. Does that make sense? So you'll get there. I'm not going to make you do it on every problem for the rest of your life. All right, so the first thing that you do is you find the 30-degree angle. There it is. So across from that, that is your S. Your hypotenuse is 2S. Then the one that you have left over is S times the square root of 3. I don't care what order you do it in, but I do suggest you do it in the exact same order every single time because that keeps you from doing weird stuff. Then we set up our little equations. All right, so I have y equals S times the square root of 3. We have x equals 2s. And I have 9 equals s. And remember, I usually start off with a pretty easy example, but then they're not always all that easy necessarily, just so that we can see what's happening. All right, so I have 2 variables here. I have 2 variables here. I have 1 here. So here, I take a look at what I have and solve if I need to. Well, it's solved for me, so that's good. So then I just take this, and I can take this 9 and substitute it in right there. So that means that y equals what? 9 times the square root of 3, and I'm done. Then I substitute 9 in here for s, so I get x equals 2 times 9. So x equals 18. And I'm done. Now, if I didn't have the 30, 60, 90 rules, could I have solved this problem and found x and y with Pythagorean theorem? No, and not got the same values. I could, but I have x's and y's in them. But I don't. So this is definitely not a shortcut. This is something that allows me to find stuff I wouldn't be able to do with Pythagorean theorem. We good? Questions? All right. So go ahead and label this next one with your s, 2s, s squared of 3. Just get it labeled, and that's it. And then we'll make sure we're all labeled right. Move on. All right, so Josh, where would S go? Okay, we'll go with X. Okay. And then where would 2S go? Okay. And that means, what do I put here? Okay, good. All right, so then, because if this is 60, that makes this 30, that's where my S goes. All right, everybody good? Go and label it in the right place. Okay. So now I'm going to set up my equations. I have 2s equals 14. I have y equals s squared of 3. And I have x equals s. All right, so two variables, one variable here. So it's not solved for me, but it's really not that big of a deal. What does s equal? 7. Okay, so s equals 7, which means that y equals what? 7 times the square root of 3. And x equals 7. And you're done. And again, wouldn't have even been able to do Pythagorean theorem if I wanted to, because we didn't have enough information for that. Okay, everybody good with all that? Any questions? All right. Go ahead and get this next one labeled. All right, so Cameron, where would I put S? With Y, okay, because there's my 30, right? Where does 2S go? Okay, and then what goes here? Okay, good. Okay, so it's labeled. Now go ahead and set up your equations, and I'm going to give you a minute to start working through it. All right, so I've got 2 variables here, 1 here, 2 here, so I have to start here, okay? Notice that here's what you don't want to do, because I've seen this a few times, and although it may not be that big of a deal depending on what problem you do it on, it can cause some issues later. Even though S equals Y, I am not substituting Y in for S right here. And there's no substituting until you have solved for the one that has the 1 variable in it. Does that make sense? Because then you substitute, and then you don't know what to do, and then now you're confused. So there's no substituting until you have an actual value. So I need to get S by itself. So what do? Good. So I divide both sides by the square root of 3, which is no big deal. Like, it looks terrible, but it's really not that big a deal. Those cancel out. So S equals 12 divided by the square root of 3. So then, danger, danger, right? So what do I do? What's it called? Rationalizing the denominator, right? You can sound all fancy. So that means so yesterday we were multiplying by the square root of 2 over the square root of 2. So what do I do here? Square root of 3. Whatever that square root is, that's what determines your fraction. So square root of 3 over the square root of 3. So that gives me 12 times the square root of 3 over what? 3. Can I reduce that? Yes. That reduces to what? 4 square root of 3. So that is S, right? So that means that automatically gives me Y, right? So Y equals 4 square root of 3. That was easy enough. Then I substituted in over here. So X equals 2 times 4 square root of 3. What does that give me? 8 times the square root of 3. Think of them as things. I have 4 square roots of 3. If I double that, that gives me 8 square roots of 3. Okay, we good? Questions? All right, good deal. Well, let's look at the next one. Okay, so here this says, find the perimeter and area of triangle ABC. Leave your answer in simplest radical form. All right, so what is this not that I kind of need it to be? 30, 60, 90, or it's not a right triangle, right? It's kind of a problem here. So, all right, well, let's just see. Instead of focusing on what you don't know, which is what the heck to do with this, you focus on what you do know, which you know how to find perimeter, right? Okay, to find the perimeter, what do you have to have? All the sides. So we're going to make a little list up here of the things that we need. So we need all three side lengths. I need the length of AB, I need the length of BC, and I need the length of AC. If I can have those three things, I can find the perimeter, right? We also know how to find area. What do you have to find the area of a triangle? The height and the base, okay? So for area, I need the height and I need the base, which is, what's the base we would use here? CB, okay, or I'm going to put BC, but yeah. So this is the base. Do I know any of that right now? I know AB, so I'm going to go ahead and put that in there. I know that that's 16. That doesn't get me very far, but I know that much. All right, well, the height is the only thing that's not drawn in here that I need. So I'm going to go ahead and draw in the height. How are the height and the base always related? Perpendicular. Okay, so I draw this in there. Well, when I draw that in there, that divides my big triangle into two smaller triangles, right? What's the measure of this angle right here? 60, because if this is 90 and that's 30, this has to be 60. So that's good. That's 30, 60, 90. I can do something with that. But I still got this mess over here. What's the measure of this angle right here? 45. 105 minus 60 gives me 45. And this is 90, so this is 45. Look at that. See? So I didn't stare at it and go, oh my God, I don't know what to do, right? I draw in my height, and then I just think, okay, what does that tell me? I start labeling things, and before you know it, you have something you can actually work with, okay? Now, in order to find all these things, yeah, I can call them AC and whatnot, but I'd really rather use variables that makes it a little bit easier. So I'm going to call this X. I need BC, but now this is parts of two different triangles, so I'll call this part Y, this part Z. I'll go ahead and label this H because that's the height, and that makes sense, okay? Now, I've got these two special right triangles that I feel like we can do something with, but they're together as one. It really is helpful to go ahead and separate and redraw them so that they're not overlapping things that get confusing. So I'm just going to redraw them and kind of break them apart. I'm not even going to put the vertices on there necessarily, just the variables is fine. So this is X, this is Y, this is H, and this is 45 and 45. And then I'll just separate this one over a little bit. All right, this is 30, 60, this is H, Z, and 16. All right, so I have two triangles here. Does it matter which one I start with? So I can start with this one over here? I only got variables, right? Like I can set some stuff up, but it's not going to get me anywhere. But I have a number over here. Like this will get me something. So I'm going to start with this one. This is a 30, 60, 90 triangle, so I have to label it accordingly. Across from 30 is S. The hypotenuse is 2S. The other leg is S times the square root of 3. So I'm going to go ahead and set these up. That means I have S equals H. I have 16 equals 2S. And Z equals S times the square root of 3. So here's where I have my one variable. I do have to solve, but it's not that big a deal, right? So S equals what? 8, which means that H equals 8, and Z equals 8 times the square root of 3. Not even a whole lot of work, right? It's just about how are things related to each other so that you can get them labeled. I'm going to go ahead and label them here. So this is 8. This is 8 square root of 3. And this is, well, I already had it, 16. Okay? All right. So now I'll look at my other triangle. Well, over here, H equals 8, right? So I've got that. Then I need to label my triangle. So is it S, 2S, S square root of 3? L, and what? Square root of 2. Okay, so everybody just pause right now and look up here. Okay? Because you've got two different sets of rules. One has the square root of 2 in it, and one has the square root of 3 in it. So one of the common things that I see that people get messed up on, if you're using the right letters, you even get the 2s and that kind of stuff in the right place, but then the square roots get mixed up or you get confused as to which is which. So here's one way that can help you remember it. The rule that has the square root of 2 in it has two congruent sides. Okay? The one that has the square root of 3 has the 30-degree angle. Okay, so kind of like try and tie those together in your brain so that you don't get the square roots mixed up. Because none of this is really that difficult, but it's easy to mess up. You know, it's easy just to use the wrong square root without thinking. Okay, we good? All right, so now I'm going to write down my little rules or my little equations for here. I've got x equals L squared of 2. I've got that h does equal L, but I know that it's 8, so that's really more helpful there. And then y equals L. Okay. And h equals 8, which does actually equal L, which is important. Sorry, we needed L more than we needed h. So since L equals 8, that's really already solved there. That means that x equals what? 8 square root of 2. And y equals 8. Okay, so I'm going to label this on here. That's 8. This is 8 square root of 2. Everybody with me? So now I'm going to take all this mess, and I'm going to label it on my original triangle up here. So this is 8 square root of 2. This is 8. This is 8 square root of 3. 16 and 8. Okay, so we found all the pieces. We're all good? Do you kind of see why having your work semi-organized and labeling things can be very, very important? We really haven't done that much work, like true mathematical work as you think of math, but there's a lot of labeling and knowing what's what. So now I'm going to come back up here and I will fill in what I have. So do I know the length of BC? No. We got to add them, right? So this whole thing is what? 8 plus 8 square root of 3. Does that give me 16 square root of 3? No. 8 plus 8 square root of 3. That's like 8 plus 8x. That's all I can do. So the length of BC is 8 plus 8 square root of 3. What's the length of AC? 8 square root of 2. H is 8, and then it's the same BC that I need again, so 8 plus 8 square root of 3. So I have everything I need, right? So now I need to actually find what they've asked me for, which is the perimeter in the area. And I don't have to think through all my craziness anymore because I have a list, right? And now I'm not naive enough to think any of you are actually going to do that kind of list. You should, but I think I would like fall over dead if half of y'all turned in your stuff and you actually had a little list there. I would just be shocked. It helps. I'm telling you. Do it from the beginning. Like, make a list of what you need so that, first of all, you're not doing too much and that you find enough, and then you don't have to think through all this mess again and pull numbers off of here. You've got exactly what you need up there. All right, so now I'm going to go down here. How do you find the perimeter of anything? You add up all the sides. So I already have them listed in my little list, right? I need AB, which is 16, plus BC, which is 8 plus 8 square root of 3, plus AC, which is 8 square root of 2. Now, do I need parentheses around the 8 plus 8 square root of 3? No, I don't need them. I can put them there, like for grouping if that helps you, but they don't really do anything, so it's fine that they're not there. So then I combine my like terms. Can I add the 16, the 8, the 8, and the 8? No. I can add those two. That gives me what? 24. Can I add this to anything? No. Plus 8 square root of 3 plus 8 square root of 2. And is that as much as I can combine? Yes. Okay, now we need units on here. Okay, units are important. That didn't give you any units, so if you're not given any units but you're expected to use them, we just use U for units. And when I do that, if I just put this U on here, the only thing that those units are attached to is that 8 square root of 2. Okay, so you have to put the whole thing in parentheses like this. Okay, so I know that, it starts to become one of those things where you blame everything on Schoology sometimes, and you're like, well, I didn't put the parentheses in Schoology, so it counted it wrong. You know why it counted it wrong? Because it's wrong, not just because it's Schoology. Because even on your paper, if there's no parentheses, guess what? It's wrong. It's not a Schoology thing. It's a notation thing. Like, it doesn't make any sense without the parentheses there. Y'all have been required to use units in the past, I know, but you probably really never had any kind of answer that had more than one term in it. Okay, so you probably didn't ever have to look at that, but that is important because those units get tied to everything. Does that make sense? Okay, so that is my perimeter. All right, so then I'm going to go find area. So we have lots of areas, right? And to distinguish between the different types of area formulas, we're going to put a little triangle here because it's the area of a triangle. It's not just an area. It's like the area of what? What is the area of the triangle formula I told you actually want to use? Because it's not the one you think you want to use. What? Good. 1/2 base times height. Because I know base times height over 2 was used a lot with you, right? Do you really want to take all these square roots and this addition stuff and put it in the top of a fraction? No, because then you're going to start making up your own math to try and simplify it because you're not going to know what to do with it, right? It just doesn't need to make your life any more complicated. This actually will make everything a lot easier for you. So then we just substitute in what we have. So we have 1/2. We know that the base length is 8 plus 8 square root of 3. Now, do I need parentheses here? Yes, this absolutely does need parentheses. Times the height, which is 8. Okay. Now, there are 3 main things that you are multiplying together, right? Does it matter what order you multiply in? No. So you've got some options here. I can distribute the 1/2 to both, and then I can distribute the 8 to both. There's nothing wrong with that. But I can also just start by multiplying the 1/2 times the 8. Okay? Because it doesn't matter what order I multiply in. So this can just give me 8 plus 8 square root of 3 times 4. Does that make sense to you? Then what do I have to make sure I do with that 4? Distribute that one. And so then that's going to give me 32 plus what? 32 square root of 3. Does that give me 64 square root of 3? No. And then, so that's really the best I can do, yes? What do the units look like on area? Squared, so it's going to be u squared. Do I need parentheses? Yes. Got to have those parentheses there. That is equal to the area of the triangle. Okay, everybody okay with that? You got to get used to weird looking answers. It's pushing you out of your comfort zone. Don't let it rattle you. Okay, go be confident in what you're doing. I know one thing that's bad about weird looking answers is you don't have an idea of whether or not it's even reasonable. You know, yeah, does it look reasonable? None of them looks reasonable anymore, right? So we'll look at that a little bit more too. But any questions? We good? All righty, then go ahead and glue that in.